This issue explores how to measure the speed of light. The speed of light was initially thought to be infinite. A lot of early physicists, such as Francis Bacon, Johannes Kepler, and René Descartes and others thought that the speed of light was infinite. Galileo, however, believed that the speed of light was finite. 1638 he had two men carry lanterns. Each climbed to a hill about a kilometer apart and had the first person lift the lantern and start timing on the opposite hill. When people saw the light, they also lifted the lanterns. Wait for the first person to see the light and stop the timer. This is a very famous scheme in history for measuring the speed of light. But because the speed of light is so fast, measurements on the ground are hard to capture. So the experiment was not successful due to the vast space of the universe for measurement. The speed of light provides a sufficiently large distance. Therefore, the measurement of the speed of light was first successful in astronomy. 1676 Danish astronomer O.L. Christiansen Romer measured the speed of light for the first time. At that time, he studied the apparent motion of Jupiter's moon Ion. For the first time, it was proved that light travels at a finite speed rather than infinite. However, because he used the radius of the Earth in the evaluation process. At that time, only an approximation of the radius of the Earth's orbit was known. Therefore, the calculated value of the speed of light is only 214,300 kilometers per second. However, this speed of light value is although the distance. The exact value of the speed of light is far from accurate, but it was the first record in the history of light speed measurement, and it's still worth remembering. Of course, after O.L. Christiansen Romer, many scientists have taken different measurements of the speed of light using different methods. The speed of light is derived to be closer and closer to the exact value, and almost 200 years later, in 1865, British physicist James Maxwell. It was first proposed that light is an electromagnetic wave. The propagation process of light is described with the concept of waves. The following year was 1887. American physicist Albert Michelson and Edward Maury. While doing experiments with light, I discovered a peculiarity about the speed of light. We know that if a person takes 100, drive a car at a speed of kilometers per hour. At this time, he saw a car beside him, a train traveling at 200 kilometers per hour, so what will he find? Anyone with basic physics knowledge knows it. If the car is traveling in the same direction as the train, then the visual speed of the train is 100 kilometers per hour. Then the visual speed of the train will be 300 kilometers per hour. This conclusion applies to almost everything on Earth. But it's not for the speed of light. The results of Michael Urson's and Maury's experiments on light. This shows that the speed of light does not follow this law. Again, take the cars and trains mentioned above as an example. It stands to reason that the speed of light emitted by a moving light source. It is certainly faster than the speed of light emitted by a stationary light source. At this point, if the light in motion intersects, then the visual velocity should be the sum of the two velocities. Whether in motion or at rest, the speed at which light travels is constant. That is, you put the flashlight on, let it glow on a still ground, and you hold the flashlight while running and let the flashlight glow. The speed of light is the same for both. It has not changed in the slightest because of the movement of the flashlight. And that's what you know when people measure the speed of light. Whether we are in motion or at rest, the measured results are constant. That is, no matter how the measure itself changes, or how the light source itself changes, the speed of light is always constant. Now it seems that no matter how you measure it, the speed of light remains the same. It seems to be absolutely eternal. It is also on the basis of this conclusion Albert Einstein came up with the theory of relativity. A new chapter in cosmological research was opened.